Hey everyone, so in this video we're going to be taking a look at the product rule. Now the product rule is a very useful theorem in calculus. It allows us to quickly find the derivative when two functions are being multiplied together. Now the first thing I want to do is explain why we need the product rule, and then after we take a look at that, we'll take a look at the proof for the product rule, or the justification as to how we know it is true. So let's start off with the why. So let's just consider two functions. Let's say we have a function f of x, and let's let this one equal x squared. And let's look at a second function, g of x, and we'll let this one be 3x cubed. So first thing, let's find the derivative of each of these functions. In each case, these are power functions. So to find the derivative, we can just use our power rule. So f prime of x, bringing the 2 down out front, our derivative is 2x. And then for g prime of x, we're going to end up with 3, our coefficient, times the 3 comes down out front, and we reduce the exponent by 1. So simplifying that, we end up with g prime of x is equal to 9x squared. Okay, now as we said, we're going to be looking at the product rule. So let's see what happens when we multiply these two derivatives together. So we're going to look at f prime of x times g prime of x. So that's going to be 2x times 9x squared. And simplifying, we end up with 18x cubed. Okay, but that's just the product of the two derivatives. Now, it's important to know that that is not the same as the derivative of the products. So to show you what I mean, let's set up another function. Let's call this one capital F of x. And this function is going to be my two original functions multiplied together. So if we substitute those in, we're going to have x squared times 3x cubed. So that means that capital F of x is going to be defined by 3x to the 5th. And now, after simplifying that, let's find the derivative of capital F of x. Again, it's just a power function. So our coefficient 3, 5 comes down, and we reduce that exponent by 1. So our derivative here, capital F prime of x, we end up with 15x to the 4th. And as you can see, these simplified expressions are not the same. So in other words, f prime of x times g prime of x, this is not equal to capital F prime of x. In other words, the product of the derivatives is not equal to the derivative of the products. So that may be a surprising thing, right? It's not the same as our addition or subtraction rules we have for derivatives. So we need a new rule. So why don't we take a look at that? All right, so to develop this rule, to derive our product rule, we are going to use our standard definition for a derivative. So I have it here written out in the limit form with our limit as h goes to 0. And then remember, the function we want to find the derivative of was this capital F of x that we defined as f of x times g of x. Okay, so now if I want to find the derivative of our function capital F of x, we're going to use our definition of a limit. But now we're going to be doing it for f of x times g of x. So the first part, we're going to be plugging in x plus h. So what we end up with is we have an f of x plus h times a g of x plus h. And then from that, we're going to subtract our original function, which in this case is f of x times g of x. And now this is all over h. Okay, and now the next step, we're going to introduce some more function notation because I want to be able to work with the numerator, and we're going to strategically split that up so that we can simplify our limits. So what I'm going to do our limit sign is going to come down. And then in the numerator, so I have my first term here, f of x plus h times g of x plus h. And then I'm going to subtract and add f of x plus h times g of x. And then I'll add that on here. Now, by subtracting it and adding it on, they're complete opposites. That would simplify to 0. So I'm not changing the value of my fraction at all. It's like I'm adding 0, but I'm putting more terms for us to work with. And then we still have our minus f of x and g of x. So that's a big long expression, and it's still all over h. Okay, now the next step, and the main reason we added in and subtracted that term, is now we can do a little bit of factoring. So if I group these up and I look at the first two terms, so I'm looking at these two terms at the beginning, both of those have an f of x plus h in them. So why don't we factor that out? If I factor that out, what I'm left with is g of x plus h minus g of x. And now I'm going to do the same thing for my second two terms. So now these two terms at the end, taking a look at what they have in common, they both have a g of x. So we can factor that out. So if we factor that out, we're going to be left with f of x plus h minus f of x. And then that would be times g of x. Okay, so what we were able to do so far is putting those couple terms in. We had opposite, so it's like we're putting in 0, but that allowed us to factor. Now, what I'm left with, in my brackets, I have g of x plus h minus g of x, and in my other set, I have f of x plus h minus f of x. Now, I hope those look familiar, because that's what we call the difference quotient, and that's how we define a derivative. So let's split this up a little bit. So we have a little bit of addition, we have some multiplication in between. So I'm going to split this up into a couple different limits. So separating this out, first we'll have the limit as h approaches 0. I'm going to separate out this f of x plus h. And then this one is going to be times, so our product rule for limits, we'll have the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay, so that takes care of these first two separated by the plus sign, so plus. Now we're going to do the same thing with our second grouping here. So then we'll have the limit as h goes to 0 of f of x plus h minus f of x all over h. And then our product rule times the limit as h goes to 0 of g of x. So as I said, what we ended up with after factoring, these are the difference quotients. So the limit of the difference quotient, that's exactly how we define the derivative. So we can simplify all of this. Our first one, as h goes to 0, so if I substitute in 0 for h, this is just going to be f of x. My second one here, the limit of the difference quotient for g, that's exactly the same as the derivative of g. And we have plus. Here, the limit of the difference quotient for f, that's the same as the derivative of f. And then the last one, here as h goes to 0, I don't have anywhere to substitute in h, so that's the same as g of x. And now this is our product rule for derivatives. So what we end up with here is we have our first function times the derivative of the second plus the derivative of the first times the second function. So it's a nice, quick little formula that allows us to find the derivative when we're dealing with products of functions.